Okay, guys, what I'm going to just work through are some problems now from the review that you guys already did. What you need to look at, though. Okay, anything from notes, any examples from notes, anything from your first quiz, anything from the quiz review, all of that stuff is fair game on your tests. So don't think just the problems I go over today is the only thing on there. It's anything that we have gone over. So if you have any other questions besides what I do, please feel free to say, hey, can we go over this one? I want to look at this one, that sort of thing. I'm just trying to touch and highlight different things. So if we look at this example that I've highlighted, what are we doing in this problem? Hello. Hi. All right, so what are we doing here, guys? We're just simplifying, right? What should we do first? Distribute what? Let's distribute that 3. Let's distribute the 3 first. So that 3 is going to go to the 4 and to this x. So I have 3x squared, and then I have 4 to the 3rd, x to the what? 9th. Power to a power, we multiply. If you're multiplying same bases, you add exponents. Just those little things you guys need to remember. So I have 3x squared. What is 4 to the 3rd power? 64x to the 9th. Guys, you might have to write down on a piece of paper or somewhere on your test, you might have to write down 2-digit numbers and multiply. That is definitely a possibility, so don't be afraid to do that. But in this case, I have 64 times 3, which is going to give me what? 192, okay. So 192x what? Where'd you get 11 from? You add the exponents because you're multiplying same base. Good. All right. I'm just going through just different problems to keep your eye on. All right, let's look at 35b. Do I have any powers that I need to distribute throughout here? No. Now, there's a couple ways you could do this. Some of you, as soon as you see this, where do you want to put b to the negative 2? On the bottom. If you want to do that, feel free. That's totally fine. If you don't want to do that, you don't have to do it as well. But I notice I have just a random old 3 by itself. It's fine. I have a squared times a to the 1st. Gives me a to the what? A to the 3rd. Then I have b to the 4th times b to the negative 2. If you have the same bases and you're multiplying, what do you do to the exponents? If you have the same bases and you're multiplying, what do? We add. When we add 4 plus a negative 2, you actually are ended up subtracting, but this would become b squared. But if you guys moved it initially, if you moved b squared to the bottom, then you would have subtracted 4 minus 2 is 2. Same thing. Make sense? Yeah. All right, when we see something like 36, some of you go into like, woo, it's fine. Just take your time, move exponents that are negative up or down. Not negative coefficients. If that was negative 3 to the 4th power, you wouldn't move it down. It's only our exponents that move. So if you would like to rewrite this, you absolutely could. You could write 3 to the 4th here and 9 squared here, correct? Then I would have an m on the bottom, and I have another m on the bottom, correct? And then I have n to the 3rd and n to the 3rd. You guys agree? Perfect. Once we get there, then you can simplify as needed. What happens with n cubed and n cubed? They'll cancel out, right? 3 minus 3 is 0. What is 9 squared? 81. What is 3 to the 4th power? Oh, hi. And then I have m what? Can I do a little more? What does this become, guys? This becomes 1 over m squared. It does not just become m squared. Remember, anything divided by itself is 1, so that 1 is still on top. Questions? We're always going to simplify where we can. All right, let's look at some other things. All right, just some basic simplification here. Some of us are still having a little bit of a tough time. If I see 44a, that says the cube root of 64 over 125. I can rewrite this as the cube root of 64 over the cube root of 125, correct? What does that mean, cube root? A number times itself how many times? 3. What number times itself 3 times gives you 64? 4. What number 3 times gives you 125? There you go, guys. You don't need a calculator for something like that. You have really good brains that you guys can use. What's the simplified version of 44b? What's the square root of 81? 9. Square root of 100 is? Perfect. All right, so if I have this, what happens when you cube a cube root? It cancels. So what's your answer here? 216. What happens when you take the fourth root of something to the fourth power? It cancels. So your answer is 32. Don't be surprised by questions like that. Don't overthink them. You guys all right? Okay. Scooting along. I made up this problem 2 minutes ago, so go ahead and write it down. You had one like this on your quiz. We had a couple of these on our class kicks, on our reviews. This is important. Again, you can just go right off the bat, you can go and rationalize. But what would be the easier thing to do? Simplify. What can you simplify? Can we simplify 5 and 105? How come? They both go into 5. Good. What's another reason that we can, though? They're both underneath the radical. So 5 divided by 5 is just 1, right? So this leaves me with just 7. Can I write the square root of 1? Absolutely. You don't have to, though. 105. I don't know just off the top of my head. Let me just write it down real quick so I don't make a silly mistake. 5 goes into 10 how many times? 2. 5 goes into 5 how many times? So I'm left with the square root of 21 down here, correct? Now what? How do I fix this? I have to multiply the top and bottom by the square root of 21. So this becomes 7 root 21 over just 21, yeah? Am I done? What else can I do? I can simplify. This becomes root 21 over 3. Perfect. Good job. All right, if I look at something like 53, guys, this has come up 17,000 times in the last 3 days. All right, guys, what's the problem? What's the problem here? Tell me. I have a radical in the denominator. What else is the problem? It's just not a random radical all by itself. It's connected. It is married to 2 with a negative sign. So we cannot just rationalize by root 3. What do we have to rationalize by? 2 plus the square root of 3. Guys, that is the first thing you need to do is multiply by the conjugate. If you're going to get any points for this question, that has to be the first thing you do. So in your numerator, when we simplify, obviously there's not much to do here. You're multiplying it by 1, so you just have 2 square root of 3. What happens on the bottom? 2 plus, I'm sorry, square root of 3. What happens on the bottom here? FOIL. 2 times 2 is 4. 2 times positive root 3 is 2 root 3. 2 times negative root 3 is negative 2 root 3. And then the square root of 3 is square root of 3 gives me the square root of 9, right? So I could just put minus 3. You guys agree? Yeah. What happens on the bottom? Those cancel, and then what's 4 minus 3? So I'm left with just this. If you can combine further, do so, but don't make up your own math. Remember, radicals have to be the same in order to combine them. If you can simplify, if you had root 12 or root 8 or something like that, simplify. You always want to simplify. Questions? Okay, let's just understand 57, 58. What kind of exponents are these called? Rational. Good. They're rational fractions. So how could I rewrite 57? What does the denominator become? The root, the index. So this is really the square root of 16 to the what power? What do we do first? Do we cube it or do we find the root? You find the root. What's the square root of 16? And 4 cubed is 64. You guys will start to see patterns. You're not going to get numbers that are ginormous, anything more really than like 6 squared or 6 cubed, 7 cubed, because the numbers get so big. How is 58 different? The negative exponent. Before you guys go to simplify, how should I rewrite that? 1 over 64 to the 2/3. You see a negative exponent, move it. Not a negative coefficient, but a negative exponent, go ahead and move it. So then this becomes 1 over what? Cube root of 64 squared. The denominator becomes the index, the root. So then when we simplify, I have 1 over. Well, what number times itself 3 times gives me 64? 4. And then I square it, so 1 over 16. Good. Yes? Okay. My stomach is growling. All right, you guys are going to have a problem or two like this where you have to simplify, and it is just combining like terms. But there's going to be negative signs, and then when we see negatives, we're like, oh no, what do we do? When you have a negative sign in front of a parenthesis, what do you have to do with it first? You have to distribute to everything behind. So this is negative 3x squared minus 2x plus 1 minus 5x. Does everybody agree with me? You see that? Soon as you see a negative, whether it's out in front, whether it's in the middle, whatever you have, if it is in between or in front of parentheses, you have to distribute throughout. So now we're going to write our answer in standard form, meaning highest exponent first, descending order. So the highest exponent I see is negative 3x squared. What else can I combine? Negative 2x, negative 5x is? Perfect. Negative 7x, and then I have plus 1. Good. Be careful. It's a real simple problem, but easily you can make a mistake. All right, same thing here. I have parentheses and a bracket. Whenever you guys have double, you have a parenthesis and a bracket. When you have different kinds of notations, you have to work from the inside out. Does that make sense? All right, so when I say inside out, I'm going to leave 8y minus right here. And then I'm going to look on the inside of my bracket. Do I have a negative sign that I should distribute? Yes. Where is it? It's right in front of that 3y, correct? So I have to distribute here and here. So this becomes 2y squared minus 3y plus 8. Questions? Before you go and distribute again, see if you can simplify anything inside that bracket. Can we? I have a y squared, a y, and a y to the 0 power. So can I combine anything yet? Inside in the blue? No. All right. So what do I do with that additional negative sign I have? I'm going to distribute that. You want to work from the inside out and then simplify. So you have 8y minus 2y squared plus 3y minus what? Minus 8. Do I have anything I can simplify or combine? Yep, the 8y and the 3y. So I'm going to rewrite this in standard form. I'm going to have my highest exponent first, negative 2y squared. 8y and 3y gives me 11y, and then I have minus 8. Questions? You good? All right, let's scoot along, scoot along. 2x minus 3 quantity squared. What does that mean? What does it mean? It's the same thing 2 times. We do not distribute the 2 to each term. This is going to be a perfect square trinomial. I would like you guys to be able to just say that the answer is what? 4x squared. What? Minus what? 12x plus 9. Right? How do you find when you have a perfect square trinomial? If you have the same binomial multiplied by itself twice, you square the first term, you square the last term, then you multiply the first term times the second term times 2. It's a pattern. If you don't memorize that, yes. Could you FOIL this? Absolutely. But in order to save time, it would be helpful if you guys could recognize the pattern. Does that make sense? All right, let's go. Let's do 74. We talked about this in the video. I don't know if everybody really got a handle on it. Your Pascal's Triangle. If you have something raised to the 3rd power, there's a couple different ways this is taught. This is how I do it. If you do it a different way, that's fine. But when something is raised to the 3rd power, we call that row in Pascal's Triangle the 1, 3, 3, 1. So what I always tell my kids to do is to take the first term, which is x. So x, 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 x. What's your second term? Negative 4. All right, just get your problem set up. Because what you're really doing in a sense is you are multiplying x minus 4 times x minus 4 times x minus 4. But there is a pattern that you can use that will simplify this process, especially when you get up to like something, a binomial to the 6th power or something. But right now we're just at the 3rd power. So the way we get our problem set up is we start with our exponent. Our highest exponent is 3. On the first term, you go in descending order. So 3, 2, 1, and 0. What is anything to the 0 power? 1. Good. On that second term, you go with ascending exponents. So you start with 0, and you go 0, 1, 2, 3. Anything to the 0 power is 1. And I like to go one step further and just simplify a little bit. So I like to go through and say, okay, well, negative 4 to the first power is just negative 4. What's negative 4 squared? 16. What's negative 4 to the 3rd power? Negative 64. And then all we do now is multiply down. So 1 times x cubed is x cubed. 3 times negative 4 is what? Negative 12x squared. 3 times 16 is what? No, so plus 48x. And then negative 64 times 1 minus 64. And there, that would be the exact same thing if you got x minus 4 times x minus 4 times x minus 4. Knowing the pattern and being able to do the shortcut will save you a lot of time. All right, how do we feel? We're okay? All right. 76 says subtract blip from blip. All right, this is a very basic problem. It's subtraction, but what goes first? The second one, 6x to the 4th minus 20x squared minus x plus 3. You want to take 9x to the 4th from this, correct? So I'm going to write it backwards. Now, you guys, I did this 2 different ways on the video because some people like to look at it horizontally and some people like to look vertically. If you're going to show me your work on this, what do I really want to see on this step? That you do what? Distribute that negative sign. I want to see this. If you don't want to rewrite it, if you just want to go boom, 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 feel free. That's fine with me. If you want to rewrite it, great. If you don't, that's fine as well. But just do something to show me you know what you're doing here. So now we can combine like terms. Find the highest exponent. I have 6x to the 4th and a negative 9x to the 4th. What is that? 6 minus 9. Negative 3x to the 4th, okay? Next exponent would be what? Okay, x squared. So I have negative 20x squared plus 11x squared. Negative 9x squareds. Now what? Minus x. Then what? Minus how much? Okay, positive 3, negative 16, so minus 13. Again, if you want to write it vertically, you want your x to the 4th, x to the 2nd, x to the 1st. It does not matter. Just show me what you are thinking in your brains. Yeah? Okay. Scooting along, scooting along. All right, what do you guys notice about 83? It's going to say factor completely. What's the first thing we should look for with factoring? Well, before perfect squares, GCF, all right? Then if you don't have a GCF and you have 2 terms, you say, oh, is this the difference of perfect squares? Difference means there's a minus sign in between 2 perfect squares. Is 83 the difference of perfect squares? Yeah, what times what's going to give me 25x squared? 5x and 5x. What times what's going to give me 49? 7 and 7. So my 2 parentheses are 5x plus 7 and 5x minus 7. Does it matter where I put the plus and where I put the minus? Nope, just as long as you have one of each. All right, GCF? 9, right? What goes into both 36 and 81? 9. So I'm going to go ahead and pull that 9 out. So I have a 9 out in front, and that leaves me with 4x squared minus 9y to the 6th, correct? Do I still have the difference of perfect squares? Yes or no? Yes. Yeah, okay. So I have 9 out in front. What times what's going to give me 4x squared? 2x and 2x, agreed? What times what is going to give me 9y to the 6th? 3y to the third, good, and 3y to the third. And what goes in between? Plus and minus. If you guys don't take that GCF out first, you will not be fully simplified. So make sure you're always looking for GCF first. Yeah? Did I write down? I did write down another problem. All right, we have not done factoring trinomials. I know you guys know how to do it, but we haven't done it as of yet. So this should kind of set off a bell and whistle. If it says, hey, go ahead and factor this. First thing we look for is a what? GCF. Good. Is there a GCF with 4, 20, and 25? No. But what do you guys notice? Anybody notice anything? 4 and 25 are what? They are perfect squares. What times what is going to give me 4x squared? 2x and 2x. Good. What times what is going to give me 25? 5 and 5. Now, in order for this to be a perfect square trinomial, it's not the difference of perfect squares because there's 3 terms, not 2. But in order for it to be a perfect square trinomial, the first term and the last term have to be perfect squares. And the middle term has to be the product of your first term times your second term times 2. What is 2x times 5 times 2? 20x. Is that your middle term? Then you know that this is a perfect square trinomial. How do you know what sign goes in your binomial? The sign with the middle term. So this would be 2x plus 5 times 2x plus 5. What is another way that I could write that? 2x plus 5 quantity squared. Good. Good, good, good. All right, you guys are ready. You guys are ready. You have all weekend. Go back over your quiz. All of those types of questions, just simplifying radicals, combining, adding, and subtracting, that sort of a thing. Anything from the quiz review, anything from problems that we've done on our notes, anything from this, please feel free. Take a screenshot of it. Send it to me this weekend and say, hey, I'm a little confused on this one. Can you go over this? Don't try to type the question to me. Just take a picture of it or write it down and take a picture and send it to me. It's easier that way for me to understand what you're asking. Then I can just pull it into Notability. I can answer the question, send it right back to you. All right? If you guys need me, I'll be here Tuesday morning for I'll be here around 7:45. So 7:45 to 8:05 if you have quick questions, whatever. But sure. All right, I will upload this right now.